Okay everyone, today we're going to be looking at finding the equations of the tangent and normal line. Okay, let's start. So the function that we want to find, the equation of the tangent and normal line, is y equals negative x squared plus 2x minus 1. And we want to look at the equation of those two lines at x equals 2. Okay, I've actually checked beforehand that at x equals 2, the y is negative 1. So how did I do that? I just have to input the 2 into the equations, and then I will have y equals negative 1. So the coordinate is 2 comma negative 1. Right, so let's start making the equation. But before we start, it's going to be helpful if we sketch the graph first, yeah? So how do we sketch the graph? We don't have to draw, but then we just have to sketch. Now, when trying to sketch the graph of a quadratic equation, okay, we need to see the coefficient of the x squared. So if you see here, the coefficient of the x squared is a negative number, so it's negative x squared. So there's actually a negative 1, so negative 1x squared. So that's the coefficient of the x squared. And because the coefficient is a negative number, then the graph is going to be concave down, or a sad face, yeah? If the coefficient is positive, then it's going to be smiling or concave up. And because it's negative, the one that we're doing, it's going to be facing down or concave down. And I also already checked in Desmos that 2 comma negative 1 is right over here. So this is 2 comma negative 1. I've checked it in Desmos beforehand. Okay, so we want to find the tangent and normal line at that point, 2 comma negative 1. So let's see, how does a tangent line looks like, yeah? So tangent line is a line that only touches one point from the curve, only one point, one dot at the curve, yeah? Sorry, my line is not straight, but you get the idea, yeah? So this is the tangent line, okay? And what is a normal line? So a normal line is a line that makes 90 degrees to the tangent line. So I'm going to draw. So this is the normal line. So it makes 90 degrees to the tangent line. So that's normal line. Okay, and both of them has m, or the slope, yeah, the slope, they have a slope of a tangent line and normal line, and because they make 90 degrees, okay, so their slope, if we combine them, so it's going to be the slope of the tangent line multiplied by the slope of the normal line is going to be negative 1. How do we know that? It's already in the previous material. So two lines that makes 90 degrees, then the slope of the m, if we multiply, is going to be negative 1. So that's how they relate. Okay, so now let's find the equation of the tangent line first. Yeah, so the tangent line, that's what we're going to find first, and then after that we're going to find the equation of the normal line. So tangent line, the equation of a line, like there's like multiple, well, not multiple, there's a few, yeah? The one that we're going to use today is, okay, so I'm going to slide the screen up, is y minus y1 equals m, and then x minus x1. Do we have to use this equation formula? No, you can use other equation formula like y equals mx plus c, that's fine. But one today, I'm going to use this one, yeah? The y, this y here, and this x here, we're going to just leave it alone. It's just part of the formula. The one that we're going to fill in is the y1, m, and the x1. That's what we're going to fill in, yeah? So let's fill in the y1 and x1 first. So the y1 and x1 is the coordinate that they gave us, or that they gave us to find the equation of the line. So it's going to be y minus, okay, let's see. What was the coordinate? It's 2 comma negative 1. So the y1 is a negative 1, okay, because it's given 2 comma negative 1. And then the m, we don't know. I'm just going to leave it as an m for now, okay? And then x minus 2. Because the coordinate that we're looking at is 2 comma negative 1. So that's what we have. So it's going to be y plus 1 equals m, and then inside the bracket, x minus 2. Now, yes, we have to find the m. Okay, the m is the slope, okay, or the gradient. we already know in previous session that the slope or the gradient of a curve is the first derivative of the function. Okay, so the function is y equals negative x squared. So okay, I need to write it down. So I'm going to scroll it up. Okay, maybe if you can't see the part above it, you can later just, you know, pause and then rewind. Yeah, so the function is y equals negative, oh, I need to see, so negative x squared plus 2x and then minus 1. Okay, we want to find the dy over dx of the first derivative. Okay, so the dy over dx is negative 2x plus 2. Okay, we want to find the m at, okay, m at, we want to find m at, okay, 2 comma negative 1. So we just have to input in the dy over dx here. So it's going to be negative 2, 2, and then this one's going to be plus 2 because the first derivative is negative 2x plus 2. So it's going to be negative 2 times 2 plus 2. Negative 2 times 2 is negative 4. Okay, you add by 2 is going to be negative 2. So the m, or the gradient of the tangent line, is negative 2. We just have to input in the equation, the one without the m. So we're going to input here. Okay, so we have y plus 1 equals negative 2 and then x minus 2. So we have that. And we're going to simplify. So it's going to be y plus 1 equals to negative 2x plus 4. Okay, or y equals, sorry, I'm squeezing, yeah. Y equals negative 2x. This one here is going to be plus 3 because you move the 1 to the other side. Okay, we have it. This is the equation, okay, I'm going to box it, of the tangent line. Okay, we need to find the other one, which is the equation of the normal line. So okay, let's slide up again. So I want to find the equation of the normal line. Same, we're using the same equation formula. So number 2, whoops, got the wrong one, sorry. Okay, second one, so normal line. Okay, so the formula is still the same, y minus y1 and then equals to m x minus x1. Okay, that's we know the y1. The y1 is negative 1 because it's in the 2 comma negative 1, and then m x minus 2. The x1 is 2 because we're still looking at the same point. Now our problem is to find the m. Okay, do you remember before I said that two lines that are perpendicular to each other, when you multiply the m, it's going to be equals to negative 1. So we actually already have the m for the tangent line, which is this one here. So this is tangent slope, tangent line slope. We already have the m that belongs to the tangent line. Now then we know how to find the m for the normal line. So it's going to be m tangent times m normal equals to negative 1. The m tangent is negative 2 times m normal equals negative 1. Okay, so m that belongs to the normal is going to be half because negative 1 over negative 2, so half. Got it? We just have to put it in the formula. So now we have y plus 1, because minus minus become a plus, equals to half, and then x minus 2. Simplify. Y equals to half x minus 1, then minus 1 again. Okay, so I move the 1 to the other side. So half times x, and then half times negative 2, which is negative 1, and then the 1 you put to the other side, so negative 1. So now the equation of the normal line is half x minus 2. There you go. So we have both the equation of the tangent line and the normal line. The equation of the tangent line is y equals negative 2x plus 3. And the equation of the normal line is y equals half x minus 2. Okay, I hope this session will be helpful. I'll see you in the next class. Okay, bye-bye.